Hi, and welcome to this new Quick Take episode. My name is Philippe Ozil, I'm a developer advocate at Salesforce, and today we're going to see how you can run end-to-end tests with the UI Test Automation Model, or UTAM in short. Before we jump into the technical details about what UTAM is, let's just have a quick refresher about testing and the test pyramid in general. There are different kinds of tests that you need to perform in order to make sure that your app has a good quality, and some of them have different requirements. Now, it all starts at the bottom of the pyramid where you have unit tests. Unit tests are essentially testing each subcomponent at the lowest level. And these are unit tests because they only consider the smallest amount of code, which is a unit or function generally. After that, you start adding more complexity to your tests and you start thinking about integration. Integration tests generally rely on your core application and also third-party systems. Like, for example, if you rely on a database or if you need to call web services, these kind of tests would fall into the integration test category. Finally, at the highest level, we have end-to-end tests. End-to-end tests can include UI testing, but also functional testing. And this is what's going to be interesting in this session today. We're going to look at end-to-end tests. So end-to-end tests are really the closest you can have to the actual end user behavior. It's a matter of testing an entire scenario with the user interface of your application. The challenge with end-to-end testing is that it's the most realistic way to test an application. However, building end-to-end tests is the most expensive kind of test you can do. End-to-end tests are generally a bit fragile. They tend to break over time. They're also quite expensive to maintain and to create. Now, this is going to change thanks to UTAM. So what is UTAM? UTAM stands for UI Testing Automation Model. It's a technology that is open source and has been developed by Salesforce. It can test any kind of application, not just from the Salesforce ecosystem, and something that is meant to complement an end-to-end test runner. So it will not replace an end-to-end test runner like WebDriver or Selenium. It will actually enhance it to make the tests more robust over time. It's such a game changer that the Salesforce engineering teams are even using UTAM internally to test lining experience and other subcomponents. So let's see how UTAM works at a glance. At the center of our attention, there is the page we would like to test. And in order to test it, we'll be writing a couple of page objects. And this is going to be JSON files that represent certain elements on a page. And the way this works is that they're modular and they're also composed. So essentially a page, the top level is a page object, but it is composed itself of multiple sub-page objects for different sections and different components up to the lowest level. Now, this represents multiple JSON page objects, and what UTAM does is that it will compile those page objects in the language of our choice. Currently, we support compilation to JavaScript, TypeScript, or Java. What happens with these compiled page objects is that they're then used by our tests, or UI tests. And these UI tests will be run with the test runner. So the specification of our test will be manipulating those compiled page objects. And when we run the test, the browser will be controlled automatically by the test runner, and the test will dictate to the browser what to do with the different elements. And the browser will then interact with our page under test based on the definition at the heart of the JSON page objects. Let's see that in practice with one of our sample apps. For today's demo, we're going to use e-bikes. That's one of our sample apps, and it's an electric bike manufacturer. We're going to look at the Product Explorer. So here you can see a range of products with some filters and some information on the selection. And what I'm going to show you now is the scenario that we would like to test with our end-to-end tests. So the idea here is that we'll start by entering a filter here. So we're going to select Fuse. This is one of the families of bikes we have. And now that we have entered Fuse, we can see that we have an updated pagination information and the list has been filtered down to the Fuse models. Now I can select one of them, for example, the first one, and when I select it, I can see the bike's details here on the right side. Now we did this, the final step of the test is actually opening the record page with this button here on the top right. And there we can see the product record page. Before we look closer at the UTAM tests, let's first take a look at the structure of the Product Explorer page. At the top of the page, we have the Lightning experience. So this is everything with the app launcher, the menu, etc. So it's composed of a navigation bar with the different tabs and the currently displayed Flexi page, otherwise known as the Lightning app page. And so we need to drill down on the structure of the page to get to this level. This is the part which we actually configure and customize the Flexi page. Now, in our case, it's going to be a page template with a 3-column layout that we built. There are 3 regions, left, center, and right, and on each of these regions we have different components. On the left, we'll have the custom component for the product filters. It's a lightning card based object with a couple of inputs, slider, and another set of inputs for entering the filter values. At the center region, we have a bunch of custom components as well. We have a product tile list that is composed of product tiles, and at the bottom we have a paginator object which lets us navigate in the page. And on the right side, we have a custom object called a product card, which is itself a lightning card composed with a lightning button icon. That's the button we click to get to the product record page. So this is the structure of the page that we're going to be testing. And in fact, all of these elements, or all of these squares and rectangles represent components and essentially page objects that we'll have to write. And let's see that now in VS Code. Alright, we're now in VS Code and we're going to take a look at the ebikes folder. Now, this is the publicly available GitHub repository that is available on Trello apps. Remember, this is a sample app, everything is open source. Now, if we look at the folders here, this is a typical structure for a Salesforce project. And if we drill down, you'll find all the metadata of our org, including the custom Lightning Web components that compose our different views. We're going to take an example for this demo. We're going to take a look at a fairly low-level component. That's the paginator. It has an HTML file, which is a markup file, the JavaScript for the dynamic logic, and the metadata descriptor here. Now, there are also 2 folders in here. There is the _test folder, which contains the unit test for jest for this component. And there's also a UTAM folder here, which contains a page object definition just for the paginator. Now, as a simple example, we're going to take a look at this JSON file here, and we're going to compare it with the markup of the component to see that we can explain a bit how this works. For the sake of the comparison, I'm going to put them side by side so that we can take a closer look at them. So on the left, we have the page object definition, and on the right, the actual markup that we're testing. If you look at the first element on the page object definition, that's the shadow element here. And this describes the fact that we're testing a web component. So we first need to break into the shadow DOM. So for those of you who don't know what the shadow DOM is, this is actually part of the web component technology. And it's a safe way to encapsulate the code that is in the component with some sort of barrier that doesn't leak in the rest of the page. There are some pretty cool videos that we've built that explain this in more detail. I'll share the links now. So now that we're inside the web component, we have a bunch of elements, and actually in this case we have only one. It's called navinfo. This is the name we gave it. We can call it whatever we want, but what's more important is below the selector attribute, and this maps the page object element to CSS. So this is a class selector for the navinfo class, and you can find this navinfo class here. So when we call get navinfo, based on the name of this, we're actually going to be retrieving this div here with the text inside it. In order to access it, we've made this public. This will generate a getter for the navinfo element. So this turns this bit into a JavaScript method that we can call to get the content of navinfo. Finally, we've added a number of methods. So look at this as a sort of shortcut to get something out of the element here. And we've created a method called getNavInfoText, and it's a quick way to retrieve the element we have here and go inside it to get some text. So element navinfo, this is retrieving this element, applying a method called getText on the node that we have retrieved. So this selects the div, and then we call getText, and we return text as string. In practice, this will return the output of this part here. All right, let's now look at our test that uses our page objects. UTAM tests are located in the ebikes folder for SAP test UTAM, and they have the .spec.js extension. It all starts with the import of the different top-level page objects. So we have defined way more page objects than this, but these are the top page objects. And remember that this is working with composition. So each of these page objects here are actually calling sub-page objects down to, for example, the paginator we just saw earlier. Another thing that you'll notice is that the page objects are located in a page object folder, and it's not here in my directory at the moment. And the thing is, we're going to be compiling our JSON page objects and turn them into JavaScript objects. So this is why we have these import statements. They're not resolved yet, but when we'll be running the test, we'll be working with the compiled page objects. I'm going to skip a bit the test setup, logging part, and etc., but I'm going to focus now on the test itself. So this is our main test, and you can see it's pretty short. It's about 30 lines. One of the key things you'll notice is that it's totally decoupled from CSS, and this makes the end-to-end tests very robust, because even if there is a Salesforce release and, for example, the Lightning Experience header changes or the code of a base component changes, our test is still going to be valid. What it does is that it starts by checking the default state of the view. So we're going to take the pagination information, and we have this method getPaginationInfo, which calls a subcomponent, so a subpage objects from the product title list. So we're going to get to the paginator page object, and we're going to call a method on it to retrieve the text from the pagination. And you can see here we're actually checking that the pagination text is showing 16 items, page 1 of 2. This is the default state when we have our sample data injected in our app. So we're checking the default pagination information first to see that our products are here. Then we're going to make sure also that there's no selection in the product card on the right side of the view, and we're just going to make sure that the text is selected product to see details. And finally, we're going to make some changes. So the first thing we do is that we're going to access the product filters page object, retrieving a pointer to the search input and setting some text, searching the fuse family. So if you remember well, we should have 4 items at this point. And that's the next thing that we do. So when we set the text, the filters are automatically refreshed, and what happens behind the scene is that the Lightning Web component for the filters is sending a request to the server to get an updated product list. It then re-renders the product title list, and that's the next step that we're going to wait. Notice that this part here is waiting for the pagination update. So there's going to be a little timeout here that's going to be running some checks that the pagination text is down to 4 items, page 1 of 1. If the filter did work as expected, we should see fewer items there. Finally, once we have our results in the pagination list, we're going to select the tiles here, and we're going to click on the first tile. Now, if you remember well, when we did this manually, the products are ordered alphabetically, so the first model is actually Fuse X1. And so that's what we're waiting here. In the next step, we're making sure that the product card on the right is showing the Fuse X1 model. Finally, once we have the selection up, we are going to click on the Open Record button icon on the upper right side, and we're going to make sure that we do navigate to the right product page. So this is the record page URL for the Fuse X1 model, and we're making sure that the right URL is being displayed. This is our test, and we're now going to see it in action. So we're now ready to launch our tests. Before we actually run them, we need to compile them. So I'm going to run npm run test UI compile, and this is going to take my JSON page objects and turn them into JavaScript objects that my UI tests will then use. So I'm going to do this. Here you can see all the custom page objects that I've built, and these are all only the ones that I built. We are also leveraging behind the base page objects that are provided by Salesforce for everything that is Lightning Experience and also base Lightning components. We can actually check the results of the compilation by looking at the page object folder here, where we'll find our page objects in different formats like JavaScript or even TypeScript, for example. The next step is now to go back and get a sign up. To do this, I'm going to run another function, npm run test UI generate login. So this will extract login information from my current Scratch org. Now I will hide this because the URL that is displayed here is sensitive. Make sure that you never commit it. Our UI tests are going to use this URL to log in and access the org. And this is the final step. Now I'm going to run another command here, npm run test UI, and this is what will trigger UTAM, but also WebDriver IO to fire a Chrome that is going to be controlled automatically and run our UI tests. So I'm kicking this off, and at this point you can see now I have a Chrome window open, and it's being controlled automatically by a test software, and it's doing all my tests, navigating through the Product Explorer, opening the right tab, selecting the right product, and opening the record page. This was quite fast, but it did quite a few things. Now, you could see behind the terminal was outputting a lot of things. That's because it has debug mode enabled, so it's pretty verbose. What is really important is at the end here, I have this part here, which tells me that my test worked. That's it, that's a wrap for the UTAM session. Make sure to check out these resources. I want to call out the UTAM website, utam.dev. This is a great website. It has the documentation for UTAM, but also great tutorials. There's a dynamic playground which showcases small examples on how the UTAM framework works, and it's really an eye-opener for people who want to learn about the framework. Then there are a couple of resources, sample repositories. There's the eBikes project, which contains some UTAM tests for a end-to-end test. There's also the two recipes projects which are shared by the UTAM team. One which is dedicated to JavaScript, and another one which showcases the use of UTAM with Java. Thanks for watching. I hope that you've learned something new today. Make sure to subscribe to our channel and let us know if you like this video. Thank you.